Hey, welcome back. We are continuing our discussion on the normal distribution worksheet. We did part 1, A and B in the last video, and today we're going to look at part 2, where we have a distribution where we're told that our mean is 100 and our standard deviation is 10. So, like in most distributions, okay, we always want to know what's our center and what's our spread. So if we were going to put this in context, we could say that the IQ score, okay, the average IQ score is 100 with a standard deviation of 10. And remember, okay, the center of our curve, okay, is a z-score of 0. If we were going to go one standard deviation above the mean, okay, one z-score, that'd be 110. Two z-scores would be 120. Three z-scores would be 130. In the opposite direction, 90, 80, and 70 if we subtract 10 from our mean. Okay, now the question we're asking here is, what's the probability that x bar is going to be greater than 125? Okay, so we know 125 is going to fall right between 120 and 130, and the probability that we're going to be greater than that. So again, the reason why I like to draw the picture is the picture is going to give you an idea of what your answer should be. Okay, we know that half the curve is 50%. We only have a little tail area shaded in here, so we know our probability is going to be very small. If you told me this probability is going to be more than 50%, then you're really not understanding what the curve means. Okay. Now, again, a z-score formula. We've used this many times in class. Sample mean minus population mean divided by the standard deviation. So, if we take 125, our sample mean, minus 100, and divide that by 10, 25 divided by 10 makes sense that our z-score comes out to be 2.5. Okay, so that's what we want to be able to accomplish first. Okay, that's really the first step, is figure out what the z-score is based on our curve. Now, normally we're not going to draw all of this into our picture. I was just kind of giving you an idea of what it would look like. We're going to go right to that formula with a little bit less of a picture and come up with that z-score. Now, okay, again, looking at your normal distribution table. Okay, this is table E, which was in your packet, and it's also downloaded on Google Classroom. Okay, again, when we want to look for 2.5 in the first column, okay, 0.9938, again, that is the area to the left. That's the probability that we would score less than 125 on our IQ score. The probability that we're going to score greater than, we have to do the 1 minus. And if we do 1 minus 0.9938, our answer is going to be a very small percentage. Based on this distribution, if the average IQ score is 100 and the standard deviation was 10, the probability that you're going to score higher than 125 is very small, okay? Less than a 1% chance. Okay, so that was our first example. Okay, let's take a look at a second example. In number 2, okay, still using the mean of 100 and a standard deviation of 10, it says, what's the probability that you would score greater than 92? Okay, so here where I was talking about, we're going to have that a little bit less of a curve, okay, picture. We're not going to draw it out as extensively. But again, I want to figure out, what is the z-score of 92? So sample mean minus population mean divided by standard deviation. And if we do that, our z-score is going to be a negative 0.8. Okay, 92 minus the 100, 8 below, divided by the standard deviation. So now we're going to go to the negative side. Okay, we have a positive side for our z-scores, we have a negative side on our table. Okay, negative 0.8 is going to be 0.2119. Okay, so that very first value there on the table. Again, that is the area to the left. We don't want to know the area to the left. We want to know the area to the right. We want to know greater than. So again, if we do 1 minus 0.2119, we're going to end up with an area of 0.7881. So the probability that you're going to score greater than 92 is very good. Okay, it's about a 78-79% chance. Okay. So in both of those problems, we were finding greater than. Okay, and number 3, the probability that your IQ score is going to be less than 80. So this time we're shading to the left side. 80 minus 100 divided by 10. Okay, negative 20 divided by 10 is going to be a z-score of negative 2. And if you look up a z-score of negative 2 on your table, okay, there's a 2.28% chance that you would score below 80. Okay, and again, when I'm looking up the area to the left, that's all I have to find. Okay, I don't have to do any 1 minus. If we jump to number 6, okay, we're trying to figure out what's the probability that a person would score between 79 and 122. So we have to come up with 2 z-scores here. 79 minus 100 divided by 10 is going to be a z-score of negative 2.10. And 122 minus 100 divided by 10 is going to be a positive 2.2. So first I'm going to look up positive 2.2. And when I look that up, it's 0.9861. So again, from this point, 0.9861 would be the probability, the area to the left. If we look up a negative 2.1, that's 0.0179. Okay. So again, I don't want that 0.0179. I only want from here to here. So again, we're going to subtract those 2 probabilities. Whenever we're finding that interval, we're going to subtract those 2. So if we do that, the probability that we are going to be in between those 2 is very good, almost 97%. So that's how we are leading closer to a word problem. Okay. Again, putting this in context, if I said to you, what's the probability that your IQ score is going to be between 79 and 122? Based on this distribution, very good. Okay, most scores are going to fall between those 2 ranges. Right? And then for the last part, for part 2, part B, okay, we'll do 1 or 2 of these together and let you try the rest. But let's look at number 3. It says this cuts off the top 20%. Okay, well, if you're thinking about a distribution, the top 20% would fall roughly over there. Anytime we talk about the top percentage, we're going to start from that right. Bottom percentage, we're going to start over here. So we're trying to find a cutoff score here. They're asking us, again, using that same, we know our center is 100, our standard deviation is 10. What score would represent the top 20%. Well, since we know X bars are unknown, we must be able to have enough information to find the z-score to be able to solve this equation. In order to solve this z-score, okay, again, I need to know the area to the left. So if this is 20%, 1 minus 20% is going to be 80%. So what you want to do now on your table is in the body of your table, okay, inside the table, I'm going to look for the value that's closest to 0.800. Now 0.800 is not exactly going to be there, but 7995 is, and that's the value closest to 80%, which is a z-score of 0.84. So that is the value that we want. Now you can solve this equation. Okay, 10 times 0.84 is 8.4. And if I add 100 to it, what we're saying is 108.4 would be the cutoff score. Okay, so take a minute to reflect on this. Okay, the average score is 100. You want to be in the top 20%. What score do you need to be in the top 20%? It makes sense that score has got to be quite a bit higher than 100. Okay, as long as you hit 109, 110, 115, 120, you're in the top 20%. If you hit 108, no, you're not in the top 20%. Okay, a lot of companies, okay, if you think about it, they use a cutoff score to tell you whether you're going to make it or not. Did you get this score on a test to be able to get that raise? Okay, did you hit this certain SAT score in order to get into this college? Okay, cutoff scores are used all the time. The key to the cutoff score is finding the z-score. You have to know the area to the left in order to find that z-score. That is the whole key to that problem. Okay. And I'm going to leave it at that and let you try those other three. And when we come back, we will talk about more types of actual word problems, actual real-life application with a normal distribution. But once again, this is used, okay? This is the nuts and the bolts. You have to understand this part of it before we can talk about the actual word problems. So hopefully you got a little bit out of this. And again, we will talk about it in our discussions. Thank you.